Welcome back, everyone, to this series of lectures on the theory and intuition behind support vector machines. Support vector machines will be one of the most recently developed machine learning algorithms we learn about in this course. Let's briefly review the recent history behind the development of support vector machines. As a quick note, the spelling of some names and journal article titles may be slightly altered from what you see online due to the various translation options from going to Russian to English. For example, spelling Alexei with a Y versus an I. This all begins in the 1960s, when Vladimir Vapnik is obtaining his PhD in statistics at the Institute of Control Sciences in Moscow in the Soviet Union. And he actually worked at the institute in some sort of capacity from 1961 to 1990. Now, in the 1960s, Alexei Chervonenkis and Vladimir Vapnik begin the development of support vector machines. And it really starts in 1963 when they published their article known as Generalized Portrait Algorithm for Image Analysis by Computers. And this is where they begin to lay out the groundwork of how you could use the support vector machine algorithm to perform image analysis, such as recognizing the digit shown in an image. Now, what's really interesting is right around the same time, there is another publication called The Theoretical Foundations of Potential Function Method, and it's published in a journal called Pattern Recognition Learning. Again, really focusing on using computer analysis for image recognition or image analysis, such as pattern recognition. And what's critical is that this publication, right around the same time as Vapnik is publishing his foundational work in support vector machines, is that it introduces the geometrical interpretation of the kernels as inner products in a feature space. Now, don't worry too much about what that actually means theoretically, but just keep it in the back of your mind, because this idea of using kernels as inner products is going to be fundamental to really expanding the use cases of support vector machines. And it's quite interesting that this publication is happening right around the same time as Vapnik's first work in SVMs. Now, in 1974, Vapnik and Chervonenkis continue their work, again publishing Theory of Pattern Recognition, expanding the capabilities of support vector machines further. And throughout the 1960s and 1970s, 80s, and 90s, Vapnik is really continuing to work further developing support vector machines. And this is why Vapnik is typically called the grandfather of support vector machines. He's working on this pretty much throughout his entire career. And in 1992, Boser, Guyon, and Vapnik suggested a way to create nonlinear classifiers by applying the kernel trick that we previously discussed in that 1964 publication to maximum margin hyperplanes. And this really takes support vector machines to a whole new level, which we're going to learn about when we discover how we slowly build up to the kernel trick. And then in 1995, Cortez and Vapnik published the SVM incarnation utilizing something known as a soft margin, even further expanding the capabilities of support vector machines. And in 1996, Vapnik, along with some others, published Support Vector Regression Machines, which expands support vector machines beyond classification tasks to actually perform regression analysis. Now, keep in mind, it took over 30 years of work to get to the version of support vector machines that we're going to be using and learning about in this course. And work continues today with improvements in implementation and performance, as well as theoretical advancements. As we begin to learn about the intuition and theory behind support vector machines, keep in mind this steady progress, because we're actually going to see it ourselves as we learn about the theory behind support vector machines. We're going to move from maximum margin classifiers to support vector classifiers, and then finally expanding this to support vector machines. And each of these ideas and different model types is going to directly line up with the history of the development of support vector machines. So it's not just an immediate leap to support vector machines. It's lots of additional ideas that gets us to this final model. So let's go ahead and begin by checking out the first development of maximum margin classifiers as a theoretical construct. I'll see you at the next lecture.